chemists primarily need the concentration of solution to be expressed in a way that accounts for the number of particles that react according to a particular chemical equation. Since percentage measurements are based on either mass or volume, they are generally not useful for chemical reactions. A concentration unit based on moles is preferable. The molarity of a solution is the number of moles of solute dissolved in 1 decimeter cube of solution. To calculate molarity of a solution, you divide the moles of solute by the volume of the solution. Let's talk about the mole. As we have observed, atoms are very small, too small to be weighted or counted individually. Nevertheless, we often need to know how many atoms or electrons a sample contains. To solve this dilemma, we use a counting unit called Avogadro's number, named after the Italian scientist Amedeo Avogadro. The Avogadro number is equal to 6.022 into 10 to the power of 23. Just as an amount of 12 is described by the term dozen, Avogadro's number is described by the term mole. Avogadro's number can be used to count anything. You could have a mole of apples or a mole of ping pong balls. You can get some idea of the magnitude of Avogadro's number by considering that if you had a mole of donuts, they would cover the entire earth in a donut layer 8 km deep. If you had a mole of basketballs, you could create a new planet the size of the earth. An aqueous solution of CaNO3 twice contains 20 mg of Ca2 plus ions in 0.5 decimeter cube. The concentration of NO3 minus in the solution aqueous solution of CaNO3 twice contains calcium 2 plus ions and the NO3 minus ions. They have given the information about calcium 2 plus atomic weight and the weight. The weight is 20 mg and the atomic weight is 40. So with this we can identify the mole of calcium. So with the information we have learned so far, if we know the moles of the solute and the volume of the solution, we can identify the molarity or the concentration of the solute. So with that we can identify the concentration or the molarity of the calcium 2 plus ions. Wait, the problem is in the question they are asking about NO3 minus ions concentration or the molarity. They haven't given any information regarding NO3 minus. So how can we solve this problem? Idea. If we find the mole ratio between Ca2 plus ions and the NO3 minus ions, then we can find the moles of NO3 minus ions indirectly. A mole ratio is the ratio between the amounts in moles of any two compounds involved in chemical reaction. To find the molarity of NO3 minus, we should know the moles of the solute and the volume of the solution. We know the volume of the solution, that is 0.5 decimeter cube. All we have to do is to find the moles of the solute. The solute is the NO3 minus. But we don't have adequate data to calculate the moles of the NO3 minus. So let's use the indirect way, that is the mole ratio. If we able to find the mole of Ca2 plus ion, then with the help of the mole ratio, we can find the mole of NO3 minus ion. So let's find the moles of the Ca2 plus ion. The formula of the mole is the weight over the atomic weight. The weight is 20 mg and the atomic weight is 40. So the mole of the Ca2 plus is the mole ratio between Ca2 plus ion and the NO3 minus ion is 1:2. So if the moles of the calcium 2 plus ion is 0.5, then the moles of the NO3 minus is 1. So now we have the mole of NO3 minus. and we know the volume of the solution as well. So with these two, we can identify the concentration or the molarity of NO3 minus. So that would be 2 into 10 to the power of minus 3.